Hello. Hello, everybody. Welcome to the stream. Just checking a couple things here. Let me know if you can hear me. Everything looks good on my end. So I think we're good here to just jump right into it. I've changed quite a few settings since the last stream. One of the biggest issues in the last stream was that the microphone kept cutting in and out. Like it would disconnect. So I have a different microphone, different setup. Things should be good now. So let me know what you think of that. For some reason that didn't start playing. That's fine. We don't really. No. What's going on? I have to be careful about what audio I guess I'm playing here. Because I also have the stream open. Okay. All right. Mike is good. Great. Thank you for the confirmation. So we are just going to jump right into it. There's this box. I have a box here. I'm going to turn this off. Let me know if the audio is too loud as well. Okay. So this box I've actually had for quite a while. Probably should have opened it a lot sooner, but sort of fell to the wayside and I forgot about it. I wanted to do it on stream though, because I think there's some potentially interesting items inside of it. So let's open it up, see what's inside without further ado, right? I need a separate screen, one more screen over here perhaps to monitor chat. Hard to make sure. Yeah, this is not dropping frames like it was before. That was bad. At least on my end, it looks like it's fine. So I'm just gonna pull back stream up. Nice. Okay. So I'm a little concerned about how this arrived, but looks pretty good. Just shoved in this little box here. That could mean that things could be able to move around on their own. Let's see. We will see. And is this supposed to be the right side up? Guess we'll see if everything just sort of falls out here. Oh. Yes, I mean sometimes you can have I mean, it could have been worse. It could have been worse, right? Definitely is some damage here. This is what I was afraid of, that anytime they make these displays, the glue that they use doesn't really work. You know, this is only or it works when they make it, and then this is so old that it just degraded and fell off. So where did this come from? I don't know. Here, maybe? Oof. Actually, that might be this one that's been banging around down here in the corner. Unfortunate, too, since they're sort of open. I'll have to see if I can fix some of these legs here. But it was... so, basically what it is a display case. For... Get this into focus here. The British Aerospace Hybrid Microelectronics Manufacturing Sequence. So I think there's bound to be some good stuff in here. The hybrids themselves are pretty cool. So there's quite a few, and it actually shows you each step. Let me get the other view up so I can actually follow along here in real time. Make sure everything is in focus. So up at the top here shows you on the far left the base ceramic substrate, and then it gets metallized, and gold conductors are added on top of that, the metal layer, and then etched away where it doesn't need it. And then I'm assuming that's resistors are placed, and then this one looks like resistors are laser trimmed. Pretty cool, plus or minus 1%. And then the last step is solders added, and then they would add components, and then they would put it in one of these empty carriers. So we get put into a carrier, wire bonded to it, and then sealed, fully sealed. So a lot of cool examples in here. I also didn't account for the fact that these are glued in place, so maybe getting this under the microscope will be somewhat difficult now that I think about it. There's quite a few different examples here. Hard to say if these chips are wire bonded or not. I think they might be. Pretty cool. Pretty cool overall. Just want to poke at some of these and see. So I can always re-glue these. Oh, and actually, are these Velcro? It just feels like Velcro. Yeah, we'll see. Yes, oh yeah, some of them they're Velcroed. Or they're supposed to be Velcroed. Or I'm ruining it. It's possible I'm ruining it. Oh no, it is Velcro. So that's a much smarter move, to Velcro it instead of whatever this was, glued into place. Or this one looks like it's Velcro, just fell off. But Velcro is a smart move, so I should be able to throw these under the microscope then. Oh no. Oh no. I gotta mute Discord. I'm sure you can hear that. If I just close Discord altogether. Alright, Discord's closed. Let's go. Okay. So, looking at the top section here, looks like they just sort of added some random bits and pieces as like examples of the different types of components. Well, they're sort of weird. There's a nice little puck there full of chips. That would be cool to throw under the microscope. That's probably a good showing for all the different pieces that are on these hybrids. And there's 2 more hybrids here. So I think I'm going to try and see if I can get this puck off. Hopefully this one's not... It's not actually glued. I think this was glued at some point, just sticky padded to it. So instead of sticky padding that, not really any sticky left. I'll just put it on a coin, and we can throw this under the microscope. So I'm gonna, let's see. We'll definitely look at these under the microscope. We can look at this other hybrid that I pulled off. I just want to see if there's anything else that sort of catches my eye. I'm sure there's a lot of duplicates. I think these are probably pretty good showings for what overall is in here. So I think these are what we're going to put under the microscope, and if we want to look at more, we can also put more. So next step is for me to move us over to the microscope. Oh yeah, I bet they were expensive. Sorry, just catching up with chat here. They look like marshmallows. I mean, you're not wrong. They definitely are. They definitely are odd, marshmallow shaped. But this one we can put under the microscope too, since it's already detached itself here. Greetings from Illinois. Good to have you here. I'm not too far away up in Wisconsin, so. Have you found a way to unlodge flip chips so that I can expose a die? There's a couple different methods to do it. None of them I've pursued just yet, but that is on the horizon, something I want to do more, because I have quite a few flip chip parts that need to have their dyes exposed. So in the future for sure. But let's get the microscope set up next, and I will see you over there. We're gonna start looking at some stuff under the microscope. So stand by as I get stuff set up here. Okay, we are back, and looks like things are mostly set up here. How's this looking? Looks pretty good, pretty good. That's all in focus. Oh, the microscope control board DNC. Oh, it shuts down. I need to figure out a way to keep this up. Let me just reconnect to the microscope controller. I'll log back in real quick. Call it something. Cool. Okay, so we have that up, and it's just showing the step sizes, and I guess I'm still something a work in progress. One of these days I'll finish the microscope controller. TBD here for sure. Let's see. Oh, sorry. Catch up with chat since I was away. The TI-59 calculator. I actually have a couple of those that I've been meaning to take a closer look at. So in the future, we will definitely be taking a look at some of those cool old calculators. They seem pretty capable for what they are. I want to start with this little puck, because that's what I'm excited about. So I'm gonna move. First, I'm gonna drop it. Luckily, all these dies are sticky attached here. We're gonna drop it right in and get things reorganized. And see what we can see. So we're sitting we're in the middle here. I'm going to readjust the step size because this is too big. Put on to 200. Okay, cool. All right, so I'm gonna pull chat up, and then I'll put chat on the side right there. Yeah, that works. That works out great. Cool. All right. So we're just gonna look at some of these parts. If you see something that you want to see closer, or that I went by too fast, just let me know, and we can go through these. There's about 20, maybe 20 dies on here. I'm assuming they're all going to be pretty old dies. I think this one has some. Yeah, that's what those pluses are. Different mask alignment marks. Bunch of different ones. I don't know if that's a number. 0494. Or yeah, it's got to be. Any more watches? You'll have to ask the watch guy. Is he in chat? I don't see him. It's pretty neat. That was unfortunate when you don't see the manufacturer. That eye though, it could be an eye right there. All right, let's go down one more step size. So that could be an eye, or it could just be some random line that was blocked on that lane. And you said right under the number you think you see a capacitor. I mean, I think these big ones could be. It's hard to tell. It is really hard to tell. This one could be this big sort of metal shape here, but that also could be, who knows? It could be. I think sometimes it's hard to see without knowing the layers underneath what exactly is a capacitor and what isn't. But maybe that's just me. Yeah. Let's zoom back out of this one. I need to automate the the Z step. Yeah, you could clean it. You could get rid of a lot of this dirt. Some of these scratch marks though, that's gonna stay. Or something dragged across it, unfortunately. Those are there. Sometimes those clean up a little bit. Let's go underneath that one. Wait, underneath this way. This one's mounted to a little piece of gold. Pretty simple though. Missed it. This one looks pretty straightforward. Nothing too exciting. And things aren't going to be in the best plane of focus either, since they're all mounted to this piece of foam. And the foam's not very level, so it'll be hard to get some of them in focus here. This one has a number and maybe a manufacturer or something. 14023H7L. Interesting. Yeah, okay. Let's move on to the next. Just keep on going here. I'll go all down and then I can go around. Because I don't need to zoom into every single one of these either. So the camera, my cell phone right here is doing the streaming, and then the actual camera is mounted up on top up here, and it's a oh, it was on the other side. It's from Omax. No, it's a A35 18 0U3. It's an 18 megapixel microscope camera, and so we're just capturing that through the microscope software. Just set back up here. It could be a little closer to see. Too bad I can't get this to focus. I have to do the manual focus mode. Yeah. So it's just we're just screen capturing the microscope software. Let's see this. We'll zoom into this one. It has some interesting features on it. Yeah, no problem. These are all pretty dirty. 741. pretty common op amp, right? 41. H. H or N or W. Yeah, big. Could be W. Oh, arrow. Neat. Other cool little registration marks. Yeah, a lot of that is dirt. And that would actually probably all clean up, but like, yeah, right there looks like either a drag mark or maybe this one blew up. Let's see. Yeah, something damaged it. At these high zooms, I need to adjust the step interval. Nice, cool. 3 down and lots more to go here. Yeah, that one definitely has a big either capacitor in the center or I don't even know. I don't even know. Keep moving. This one's got an interesting design to it. Very symmetrical. 19020 in the bottom right corner there. I feel like I've seen something similar to this. A laser trim resistor? Yeah, definitely. We can pivot. We can pivot out of here, except I don't know how soon it will be for me to find a laser trim resistor on that. Just trying to see. I'm sure one of them will eventually. It's gonna be easy for me to get these out of here. Yeah, we'll keep going until we come across one. I'll be sure to point it out. I haven't seen any on any of these yet. They're usually very, very obvious when you see them. We'll just keep going. I'm sure we'll run into one eventually. Yeah, there is a lot of interesting stuff here. I mean, I couldn't tell you what a lot of it is without sitting down and really analyzing it piece by piece. Unless it's something I've seen before and then I already know, but or at least on a block basis, I could tell you what some of the blocks are. Say BK. Two frames per minute? Oh no, is it bad? Is the stream really laggy? Okay. You got me. I thought I addressed everything, but this is the first test run, so definitely if something looks bad or sounds bad, let me know. BK. Good. Cosmo's just messing with me. Let's keep going. Okay, that's one we just looked at up. Interesting, these have all been different so far. This one might have something. It's either manufacturer's mark or I don't know what that is. A logo. Burger King. Oh, Burger King. Yeah. Right. For BK. What about BB? Interesting little circle square next to it. I don't recognize that. And it's interesting too because there's almost like on the layers below it a different cutout. Weird. Oh yeah, I need to. That's what I need to do. I meant to add marks to the screen for the sizes, legends, display bars. Oh, it could be. You never know. Gotta follow the clues. Okay. Move all the way over to the side for this next one. Just held down for too long. Okay. What do we got? I mean, they're all different, but they all sort of look the same. So it actually looks like we may have seen one that looks almost like exactly like this one. I'm just gonna skip this one. I'm really looking for cool new stuff we haven't seen. It looks like it has a big transistor on the right side here. I'm just gonna keep going. Yeah, if you want to see something or I'm going too fast, just let me know. I'll just come back. There's some interesting designs in the corner. They're just a random sort of letters and numbers. Nothing too exciting. Nothing that exciting. Yeah, same with these. A lot of these I think are just going to be. I mean, it's a nice design. I like the way that the it's sort of laid out there. I like that. I'm just gonna keep going. We saw that one. Oh, another BB chip. Just saw that one as well. What about this one up here? A little bit more complex. Bunch of letters and numbers all stacked on top of each other there. Silly. There's like a number. That's crazy. They wrote a number in one of the lower layers, 54L 590. So potentially that's a standard transistor logic, or whatever logic gate series, 54 series logic gate, whatever a 590 is. You Google it. You never know. I don't know. Off the top of my head, I don't know all of them. That would make sense that we would find some just standard logic gate ICs. This one's pretty big. Wait, slow down. Yeah, a lot of features. Just a bunch of more layer marks, revision marks. I'm excited. For nothing. It's interesting that that one pad is like tarnished. It's very strange. The pad next to it is like perfectly fine, like you'd expect. Oh, huh. Weird. I think we're almost halfway done with this little puck here. I still haven't seen any laser trim resistors, unfortunately. In this one. A few duplicates. Yeah, quite a few. By hand, as far as I'm aware. A lot of them were just drawn by hand. Which, on one hand, seems like it'd be fun to do, and then on the other one, it sounds like a nightmare. You gotta make sure you draw everything perfectly. This is a weird one. I don't know what to think about it. It's got some nice sort of repeating structures though. Very cool. Not bad. That's pretty nice. Interesting border around it. I see some text in the bottom corner there. Come back to that. Very nicely defined layers on this one. I mean, that is a good question. What I haven't found any for sure markings on these yet in terms of layers. The only, let's see, I was looking at the module that's completed over here, and it might be from 1980, depending on how you interpret that string of numbers. So these would probably be around, I'd say, sort of 70s, early 80s, late 70s, early 80s. That'd be my guess, at least. Thanks. I appreciate that. Appreciate your comment. Wait, this one's got a bunch of numbers on it that I don't understand what they are. And then some other ones in the bottom corner down here. Weird. I don't know. I don't know what any of it means. Cryptic letters. They meant something to somebody at some point. I think I skipped this one in the center here. Just a little one. Actually, we've seen I think that one or similar to it. Have we seen this one? 6870. Looks like this could be. There's six similar structures, and it sort of looks like four transistors per structure. 3. I don't know. It could be just a simple 6-port buffer, or it could be a 6-port inverter, or maybe it's only 3. I don't know. I'd have to analyze it. One's big. Do we look at this one? This one's the same as the one that's in the center that we started with. Look at this one, the first one we looked at. I think there's just this one left. Oops. Going too fast. Ah, okay. So I think this one is RCA, I believe. Could be wrong. I think this CD in the bottom down here is common for RCA parts. Or I'm misremembering. It's a very nice looking part though. You are correct. So currently on this microscope, the way that it's set up with the tube on the camera, the maximum that I can do is a 50 times optical on the eyepiece, or sorry, the objective down here, and then the camera has another multiplier on it. And so this would be on the base when we're at a 5x. This is 50. This would be 100 times magnification. 200. And then the last step is 500. Whoops. Let's knock that over. That's crazy. And so yeah, that's optical. And I think a lot of times if you're trying to get like a digital microscope, you're just looking at what's available on places like Amazon or eBay. They'll say the digital microscope has a magnification of 1,000 or 1,500, some insanely high number. And from what I looked at least on the digital microscopes that I compared in the one video I did, they are nowhere near the magnification. And then I think the second thing is you need a good light source, and so that's what this microscope does. It's a metallurgical microscope, and it has forget what the term is for it, but basically it shoots light down onto the subject. You can see, maybe if I can get you closer, you can see that it's maybe not, the light's getting too washed out. Basically it's shooting light down, and then that light gets reflected back up, and that's why the images turn out so nice, is you have that light source. And with those digital microscopes you don't have that, and things look bad. Maybe one day they'll make a good little digital microscope for looking at chips. So this was the last one on this little puck. So next I think is this hybrid thing from the display. So I expect that we're going to see a lot of the same chips on here. I just want to see if there's something interesting to look at first. There's one in the bottom corner here. It's catching my eye. It's lined up here. Readjust our focus. Very interesting. Yeah, so potentially another RCA part potentially here. And so the center part, the center area, if you notice, looks different than the outsides. And that's because there's nothing connected there. So they had the ability to have, looks like 6 total copies of whatever this circuit is on the left or the right. And for whatever reason, they didn't connect up these transistors and whatever other parts are in there. They just left them in the design, but they're not connected, which is something you sometimes see. Why not delete them all the way? I don't know. That's a good question. Maybe you only have when you do it this way, you only have to change one of your masks. You have to make one new mask instead of making all of the masks new. And so this saves you time and money in terms of mask development. Interesting destruction over here in the corner. SL157H. Hard to see there. Yeah, the CD again. I think this is RCA. I could be wrong. You just go to the next one nearby here. I'm still looking for a laser trim resistor. Oh, so this is I should know this one. This is a very common part number. 54LSN. Thought it said 00, but actually 10. Which let me look it up. Let me look it up. Look on Google here. 54 LS10. What type of logic gate are you? This is a triple 3-input NAND gate. Do you believe that? Do I believe that? I guess I could believe that, yeah. There's three sort of areas. Bottom left, bottom right, and then top right, that if you trace it out, I'm sure you would see that it's a triple input NAND. And then there's 3 of them. Yeah. And then again, for some reason, whatever reason, they did not populate the top NAND. Who knows? Who knows why? Next, go to the nearby one. These all look a little broken, disheveled pieces here. Cool design. 54, and then they don't tell you the number. LS 54 41, maybe? Who knows? It's cool to see. These ones are interesting. It's like they soldered it to the ceramic substrate, but first they put it on a piece of metal. So they attach the die to a piece of metal, and then they solder that piece of metal to the ceramic substrate underneath. Very interesting. Like I've seen construction like that before. Here's a part of a chip. There's logic gate part. 54LS37. Don't know what that is, but it does have got 4 copies of something. A quad. But it's like a quad 2 input. I don't know. NAND or NOR. Interesting. In the bottom corner down here. Oof. That one got a big chunk taken out of it. And big. Which, I mean, is bound to happen when you have this part just sort of exposed here. This one looks bad. Are those cracks? Or is it dirt? It looks like dirt. Almost like mold or something was growing on it. Some fungus. Maybe it's just some little fibers. Weird. Spores. I mean, I wouldn't be surprised if that's what it ended up being. But I'd say maybe more likely it's fibers. I don't know. Could be fungus. Yeah, this chip is seen better days, that's for sure. I feel like we've seen this one, duplicate of this one. I'm gonna move all the way to the other side of this device because I think these are all basically the same little logic gates. Potentially some interesting pieces up here. Nope, that's the same one, I think. Or very similar at least. But what about this big one? Big one's gotta have cool stuff on it, right? Well, this one's even worse than the other one. Dang. Zoom in here. Interesting that some of the chips have this phenomenon on them and some of them don't. Very strange. Not seeing any identifying information on this one, so we're going to move on to the next one. Oh, hard to zoom out. Nice. Another shattered. Sad chip. One big one right above it here. copy of the other one that we just saw? Hard to say. $75.63. What do I do? This or that? Looking at the chips on the microscope? Is that your question? I enjoy it. I just like looking at the chips under the microscope, and turns out other people do as well. Even though I may not understand all of it. It's exciting to me to see all of the sort of technology that we don't give a second thought. We take for granted every day. But there's computer chips and stuff like that in everything that we use, and sort of just shedding light on that. It's definitely a hobby. We can see any of these shadowed layers here. Pretty cool. And the depth. Nice. All right, I think we've seen everything on this one. I'm just trying to look and see if there's anything on any of the other modules here that might be worth our time. This one definitely does. Let me pull it off of here. Hopefully it's velcroed like the other ones. Okay, come on. All right. So this one has a couple big looking chips in it. So the one at the top left over there, and the one sort of middle, I think are two interesting ones we can take a look at. Bigger means there's probably cool stuff on there, or at least there's more stuff to look at. Bigger is better chance. Let's just first zoom out here and see. I'm gonna skip this one. See what we can see. Whoop, too far. Can we see this one already? This one on this puck? Oh, yeah, it is. It's already on. We've already seen this one. Be a bit clearer. Well, what about the other one? Here's one of the hybrid laser trim resistors. So you can see you can sort of see where the laser came in and burned away material there, and that generates a specific resistance on the piece that remains on the right here. So you're tuning the resistors precisely, and you can do the same thing on the resistors in silicon. So if I find an example, I will definitely share it here. So far I have not seen any on a silicon chip. in this live stream. Maybe bigger is not better. Yes. Lots of MEM sensors. I think I'll throw one underneath. Just want to look at these last ones on the other side here. That one's interesting. Square in the middle. Oops, reached the end of travel there. Oh, there's a box. What does the box say? Well, yeah, I'll throw a MEM sensor underneath the microscope here. A5JEA. And you can see a sneak peek. Yeah, I think the remaining chips that are on here are going to be largely the same as what we've seen so far. So let's switch it up here. And here's a MEMS sensors promised. It's actually a video I'm working on editing right now. Whoops, don't do that. Be back. So it's on one of these cans. Be able to read that. Analog devices, something or other. I can't remember the part number. Let's take a look at a MEMS accelerometer. A very old one. From Analog Devices, 1995. Part number somewhere around here. There it is. That's the Analog Devices XL05R1. And the MEMS device, MEMS portion is the center right here. So you can't really tell until you zoom in really far. Yeah, but basically there's a weight, or just like a big mass, and as this part experiences an acceleration, the mass moves, and then you can sense a change in capacitance. Or at least that's the theory on other MEMS accelerometers. Yeah, so the central mass likely moves, and you can measure the change in capacitance and do a bunch of math on it and convert it to an acceleration. Something like that. Yes, this will be another video I make on this one. Got it opened up the other day. And then before we end stream, I'll give you one more sneak peek here. Something else I'm working on. Which one is it? For those of you who stayed around, or if you just happen to join right now. There's this chip here. Why are the colors? That's a great question. I think it has to do with different materials, but I could be wrong. So different materials that are used on the chip will exhibit a different color, especially depending on the thickness. I think is a critical component to that as well. The thickness of the layer. And this chip has two doodles on it. It has a very fancy Easter bunny. They're very dressed up for Easter. Political statements. Have I ever found any political statements? I don't think I have. And I'm trying to think if there's any other ones that have been documented. I wouldn't say that they're not, but I have not. Personally, I have not. And then over here is the other one. Looks like a worm, also with a bow tie, and then each designer on this chip put their initials into it. I have a nice little fun thing to do after you finished your. Let's see, rotate this. You finish your chip, and then you get to stick your name on there. Very cool. Yeah, a lot of detail in that one. Kind of gross looking. I'd look at it for too long. All right, so I'm gonna put you back over to the main camera here. Actually, can I just do this live? No. I'm gonna be right back. Move you back over to the other tripod, and then we can wrap this up. So stand by 1 second here. Is it working? Nice. Cool. Oh no, you heard the USB? So the software that I use, it's not smart enough when I rotate the phone for it to automatically adjust if it's in portrait or landscape mode, so I have to manually turn it off, turn it back on. Takes a second to get back here. But we're looking good. Sometimes I do lives. Every time I find something cool on eBay that I think would make a good live stream, I'll do that. And sometimes we just look at other chips. So this is what we're looking at this time. This cool display box opened up at the beginning, and we looked at some of the chips. So one of the pucks here had a bunch of different chips attached to that, so we threw that under the microscope. We looked at basically every one on there, and then some of them from these modules, we threw these under there as well. Very cool Velcro idea, though. I like that. Yeah, some of the labels fell off, and then this guy fell off and got damaged a little bit. So see if I can straighten those pins out and get him back in his spot that he's supposed to be in. Fix that back together, and have a cool little comparison example that someone put together. Trying to figure out where they would have displayed this. Maybe just at like a trade show to show what they're capable of, their capabilities are. Oops, stuck on there. It's got some cool transistors we didn't look at on those ones. That's okay. But yeah, that's gonna do it for this stream. So I appreciate you guys all joining and following along with the stream. It means a lot. And there's a lot more stuff to look at in the future. So yeah, thanks for sticking through the stream, and we'll see you in the next one. Take care.